No, it's not teaching like that.
Okay, yeah, this one.
We are waiting, we are waiting. Aja. Okay, I get 3 minutes. You have a tendency. Really, I really not want to. You are scared.
Scared of what?
Getting 300 a week.
No, I'm not scared. I'm just getting myself informed. I know I can get it.
Okay, you are not informed before.
Yes, I'm getting it.
Okay, I get it. Someone will be trying to do lapses.
Honestly, all these things, I've not at all, one of it, I've not been taught before. And the next thing, all these things, I like, it's a small work, that we did with a small work.
That in all schools, they don't teach all these things. Including ISL, I will come out. Because they are not. Do you know why we know how to teach this thing? Because we've been teaching tutorial. We are not made for school, we are made from school. And tutorial people, we teach without having book, we teach you some past question every year. We see different past question to prepare jam every year. In school, it's just in school. The teachers in the school, they just in the school. Okay, someone has tried. For physics, please keep joining. Keep joining. For physics, we are going to look at sound wave. Please, if it is not clear, let us know. I hope this one will be clear. Will be cleared. Let me put it like that, English language. I know this one will be cleared. The clarity of this one will be strong. Will be okay. Not like the first one. We are going to look at sound wave. I'm checking it myself from here to see the clarity. It's still clear. Sound wave. Please, and I want you to listen with all your might, all your soul, because in German WAEC you can't escape 8 questions, 6 questions, 5 questions on sound wave, and they are simple. They are simple questions. Sound wave is clear. Sound wave. How many people have joined us? That's okay. The 3 next time. What is sound? Right. This is a mechanical wave. This is a mechanical wave. Sound wave.
Mechanical.
Yes, sound wave. Sound wave. This is a mechanical wave. Mechanical wave that requires material medium, that requires material medium for its propagation. For its propagation. This is a mechanical wave that requires material medium. This thing should not form for its propagation. This is a mechanical wave that requires material medium for its propagation. Please, if you encounter anything like clarity in the video, please let us know immediately so that I can change the method of my teaching. Please, so that I can change, because as I'm looking at it from here, it's still clear from here, it's still okay from here. If there's anything, please let us know. Let us know. Please let us know. Right. Sound wave is produced. Write it down. Sound wave is produced by the collision of particles. By the collision of particles. By the collision of particles. By the collision of what? Particles. Creating, alternating by the collision of particles. Sound wave is produced by the collision of particles. By the collision of particles. Sound wave is produced by the collision to collide. Collision of particles. Collision of particles. Creating, alternating, creating, alternating compressions. You have to know the meaning of compression. I will still explain it. Creating compression. What is the meaning of compression? Region with high pressure. Creating compressions and rarefaction. What is rarefaction? Region with low pressure and rarefaction. Take note of that. Creating alternating compression and what? Rarefaction. Creating an alternating compression and what? Rarefaction. Creating alternative rarefaction and what? Compression. Take note of that. Take note of that. Take note of that. Hope is still clear, class. Hope is still clear. Okay, let's move now. Let's move. Class, if they ask, it's still clear. If they ask, what is compression? What is rarefaction? This is how sound wave move. Sound wave move by collision of particles, creating alternating or compression and what? Rarefaction. I told you compression is a region with what? High pressure. Rarefaction is a region with what? Low pressure. This is what they mean. When you have something like this, when you have this, when you have this, when you have this, look at this, look at this, look at this. Let me stop here. Look at this part. These lines, they are very close together. Where they are very close is called what? Compression. But look at here, the particles are what? Far away from what? One another. This is what? Rarefaction. Here they are very close, compression. Here they are far away, rarefaction. What is compression? A point on a sound wave. Don't forget, sound wave is an example of longitudinal wave. It's a point on a longitudinal wave where the air pressure is what? Above normal. Where the air pressure is high. Compression. Right. This is a region. Compression. Right now. Compression. 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 This is a region on a longitudinal wave. Longitudinal wave. Longitudinal wave. Longitudinal wave. Longitudinal wave. Take note before I move. Sound is an example of a mechanical wave based on medium. Sound is an example of a longitudinal wave based on direction traveled by the wave. I explain. Sound wave is an example of a mechanical wave based on medium. Why? Sound wave is a mechanical wave because it requires material medium. Sound wave is a mechanical wave because it requires material medium. Sound wave is also longitudinal wave. It's also an example of longitudinal wave based on its direction. Based on direction, sound wave is longitudinal wave. Based on medium, sound wave is mechanical wave. I repeat myself. Based on direction, sound wave is what? Longitudinal wave. Based on medium, sound wave is what? Mechanical wave. Hope you are following in class. Based on medium, material medium, sound wave is what? Mechanical wave because it requires material medium. Based on direction, sound wave is what? Longitudinal what? Wave. Then what is compression? Compression, this is a region on a longitudinal wave where the air pressure, is high, where air pressure is high or above normal, where air pressure is high or above what? Normal. Compression. This is compression. Where the air pressure is what? High or above normal. This is how sound wave moves. Why? Because it's an example of longitudinal wave. The region where the air pressure is high above normal. That is compression. Then what is rarefaction? Rarefaction now. Rarefaction or rarefaction. That means opposite of this. You can write it down on your own. Rarefaction is opposite of compression. This is a region. This is a region on a longitudinal wave. On a longitudinal wave. Longitudinal wave. Where air pressure is low or below normal. Where air pressure is low or below normal. Thank God it's clear. Thank God it's still clear. The clarity is still there. Please take note of that. Take note of that. Take note of that. Please take note of that. Hope you now understand sound wave is a mechanical wave. Why is sound wave a mechanical wave? Because the particle collide. Once the particle collide, they will require material medium. It's a mechanical wave because it travels through what? Medium. You understand? And sound wave is also an example of what? Longitudinal what? Wave. Take note. Take note. Let us type. Types of sound wave. Types of sound wave. Types of sound wave based on frequency. 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 Let me check. Maybe someone send message. Types of sound wave based on frequency. Types of sound wave based on what? Frequency. Someone asks, can the air pressure just be normal? No. 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 Air pressure can only be above normal or very low, below normal. Air pressure can be high or low. When it is high, it's compression. When it is low, it's what? Rarefaction. Take note of that. Take note of that. Take note of that. Take note of that. Please. It's good. Ask your question. I will read the question and I will explain the question. And I will explain the question. Right. Types of sound wave based on frequency. Number one. Type of sound wave based on frequency. Number one. Infrasonic sound. Infrasonic sound. Number two, sonic sound. Sonic sound. Number three, ultra sonic sound. Types of sound based on frequency. Number one, infrasonic sound. This came out in what? Wire question. Physics, before they changed the question, because they changed physics wire question. This question came out. They say define ultrasonic sound. Ultrasonic sound. We are going to look at it very simple. Types of sound based on what? Frequency. Number one, infrasonic sound. Right, infrasonic. This is a sound, infrasonic. Infrasonic sound. Infrasonic sound. This is a sound that has frequency below 20 Hertz. 20 Hertz. The unit of frequency is what? Hertz. Take note. The unit of, hope you can hear it, you can see it, please. I'm sorry, so that we can, those online too can benefit. Okay. Infrasonic sound. I said, this is a sound that has frequency below 20 Hertz. Frequency below what? 20 Hertz. Sound that has frequency below 20 Hertz. Hold on, you are moving. Hold on, you are moving. Oh, no question. Oh, no question. In the absence of question, let's continue, please. Okay. Class, listen. What is characteristic of infrasonic sound? This is a kind of sound that is not audible. It's not in the range of what hearing for human being. It's not. Yeah, it's not audible. We can't hear this sound. Man cannot hear this sound. Infrasonic sound is not audible. We can't hear it. Then the next one is what? Sonic sound. Sonic sound. Sonic sound. This is the sound. This is the sound between 20 Hertz and 20,000 Hertz. This is audible. This sound is audible. Is audible. Human being can hear this sound. The kind of sound I'm producing is what? Sonic sound. The kind of sound you produce is what? Sonic sound. A sound that has frequency between 20 to what? 20,000 Hertz. 20 to what? 20,000 Hertz. That is what? Hello? Hello? Okay. Everyone come. Okay. This is the sound between 20 Hertz and what? 20,000 Hertz. Next one, ultrasonic sound. 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 This is a sound. This is a sound that has frequency above 20,000 Hertz. 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 Okay. What do you say?
Can you cause deafness? Can it cause deafness?
If it's too much, I don't know. Yes. And this ultrasonic sound has application, right? Application of ultrasonic sound. Application of ultrasonic sound. Application of ultrasonic sound. Application of ultrasonic sound. It is used in medical scanning. It is used in medical scanning. Application number one. It is used in medical scanning. Yes. It is used in medical scanning. Ultrasonic sound. It is used in medical scanning. 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 Ẹ ká sọ̀rọ̀. Ó yẹ ó ṣe ẹ̀ lọ sálẹ̀. Ok, tó wá ti dé lọ. Yes. Okay, I said it is used in medical scanning. Number two. Number two. Number two. Number two. It is used in industrial cleaning. It is used in industrial cleaning. It is used in industrial cleaning. It is used in industrial cleaning or cleansing. In industrial what? Cleansing. It is used in industrial cleaning or cleansing. It is used in industrial. For example, if you want to remove what? Dirt from jewelry. If you want to remove dirt from jewelry, if you want to remove dirt, I'm sorry, because of the call. If you want to remove dirt from jewelry, dirt from lens, dirt from mechanical equipment, we use this word, ultrasonic sound, to remove dirt. Number three, it is used in sterilization. It is used for sterilization of medical instruments. It is used for sterilization. Three, it is used for sterilization. Sterilization. It is used for sterilization of medical instruments. To sterilize medical instruments. If you want to sterilize medical instruments, we use what? Ultrasonic sound. Number four, it is used as a sonar. Sonar. S-O-N-A-R. It is used as a sonar. It is used as a sonar. Sonar. It is used as a sonar. Sonar means sound, navigation, and ranging. Sound, it is used as a sonar. Sound, N is for navigation. Navigation. A is for and ranging. It is used as a sonar. Sound, navigation, and what? Ranging. It is used as a sonar, sound, navigation, and ranging. What does it mean? If you have ship on the surface of water and there's barrier under the ship, under the water, there's barrier under the water, we use what? Sound to detect that barrier or that object that can stand as a barrier in water. It is used as what? Sonar, sound, navigation, and what? Ranging. Take note of that. Take note of that. Let us try. Factors affecting sound wave. Oh, before that, listen, before that, if they ask you, before that, you say, how many media can sound travel through? If they ask you, how many media can sound travel through? Sound can travel through 3 media. Take note. Sound can travel through what? 3 media. Take note. Sound can travel through 3 media. Which are 1, solid, 2, liquid, 3, air. Let me take it as what? Gas. Solid, liquid, and what? Gas. Sound can travel through 3 what? Media. Take note of that. Sound can travel through 3 what? Media. Sound can travel through three media. Sound can travel through three what? Media. Solid, liquid, and what? Gas, air. Take note of that. Take note. Sound travel fastest. Take note. In solid than any one of the two. So, right now. Sound travel fastest in what? Solid than any one of the what? Two. Sound travel fastest in solid than any one of the what? Two. Write it down. Please. Write it down. Write it down, please. Sound travel fastest in solid than any one of these two. Sound fastest in solid than any one of the two. In that. For example, in jam, you have this question. In jam, you have this question. In jam, you have this question. Number one, number A, you have kerosene. B, you have water. C, you have iron. D, you have air. If they ask you, sound travel fastest in which of the following what? Media. The answer is what? Iron. Take note. Hope people online, hope you can understand. Hope you can understand. People online, hope you can understand. People online, hope you can understand. People online, hope you can understand. Huh? Hope you can understand. If they ask you, sound travel fastest in which of the following? The answer is what? Iron. Sound travel faster in metal than in liquid. It travel faster in liquid than in what? Gas. Take note. Right. Factors affecting the velocity of sound. Factors affecting the velocity of sound wave. 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 Let's look at factors affecting the velocity of sound wave. Factors affecting the velocity of sound wave. Okay, factors affecting the velocity of sound wave. Number one, nature of medium. Nature of medium. Number two, temperature. Number three, direction of wind. Direction of wind. Number four, density of medium. Number four, density of medium. density of medium. Number 4, density of medium. Factors affecting the velocity of sound wave. We have nature of medium, temperature, direction of medium, and density of medium. These two can almost be explained in the same way, but there's a formula I need to give you under this density of medium. Number 1, we have nature of medium. Number 2, temperature. Number 3, direction of medium. Number 4, then note. Right, note. Pressure has no effect. This question came out Jan 2004. Jan 2004. Pressure, note. Pressure has no effect on velocity. On velocity or speed of sound wave. Pressure has no effect on velocity or speed of sound wave. Take note of that. Pressure does not affect velocity or speed of sound wave. Take note of that. Pressure does not affect velocity or speed of sound wave. Pressure does not affect velocity or speed of sound wave. Right. Let's take the first one. Nature of medium. Nature of medium. Nature of medium. Take the first one. Nature of medium. Nature. Number 1. Nature of medium. Nature of medium. Nature of medium. Class, I told you that sound can travel through 3 media. Those media are solid, liquid, and what?
Air.
Gas or air. That is an example of gas. Take note. And I told you, sound travels faster. The velocity of sound in solid is higher than the velocity of sound in what? Liquid. The velocity of sound in liquid is higher than the velocity of sound in what? Gas. Write it down. The velocity of sound in solid is greater than velocity of sound in what? Liquid. That of liquid is greater than that of what? Gas. The velocity of sound is greater in solid than that of what? Liquid. And that of liquid is greater than that of what? Gas. Why? Why? Take note. The particles of solid are closely packed and vibrates more effectively than the other two media. Take note. The reason is that the particles are closely what? Packed. The particles of solid are closely packed and vibrate more effectively than the other two what? Media. Take note. The reason is that solid particles are what? Closely packed together. They are closely tied together than liquid and what? And gas. Because of that, solid can vibrate more effectively than liquid. It can vibrate more effectively than what? Gas. Take note of that. That means sound travel fastest in what? In solid than any one of the two. And travel faster in liquid than what? In gas. Take note of this. Velocity of sound in solid. Velocity of sound in solid is approximately 5,000 meters per second. Take note. Velocity of sound in solid is approximately 5,000 meters per second. That means in solid, sound can cover 5,000 meters in 1 second. Approximately 5,000 meters in 1 second in solid. Velocity of sound in solid is approximately 5,000 meters per second. Velocity of sound in liquid is approximately 1,500 meters. 1,500 meters per second. Velocity of sound in liquid is approximately 1,500 meters per second. 1,500 meters per second. Velocity of sound in air is approximately 340 meters per second. Velocity of sound in air is approximately 340 meters per second in air. That shows that sound travels this one fastest in what? In solid. It can cover 5,000 meters in 1 second. But in liquid, 1,500 meters in 1 second. In air, 340 meters in 1 second. It shows that sound travels fastest in what? Solid than in other two medium. The second factor, temperature. We are going to stop at this one. Temperature. Hope that is clear. Temperature. How does temperature affect? Write it down. Velocity of sound increases. Velocity of sound increases. Pressure what? It increases. Take note. Velocity of sound increases as temperature increases in what? In gas. When you have increase in temperature, velocity of sound increases. What is the reason? Right. The reason is that if particles move faster and collide frequently with an increase in temperature. Particles move faster and collide more frequently with increase in temperature. When there is increase in temperature, the particle of sound move faster and collide more frequently. The particle of sound move what? Faster and collide what? More what? Frequently as temperature increases. As temperature increases, particles move what? Faster and they collide more frequently. Take note of that. Then take note of this statement. Note the velocity of sound in gas is directly proportional. Take note of this. Is directly proportional to the square roots of absolute temperature. To the square root of absolute temperature. Take note of this statement. Velocity of sound wave in gas. Velocity of sound wave in gas is directly proportional to the square root of absolute what? Temperature. Velocity of sound wave, take note of this, we are moving to calculation gradually, is directly proportional to the square root of what? Absolute what? Temperature. Absolute temperature. Take note of this word, absolute temperature. Take note of this word. That is, the temperature must be in what? Kelvin. The temperature must be in what? Kelvin. That means the temperature must be in what? Kelvin. That's the meaning. The temperature must be in what? Kelvin. Then let us change this expression into mathematical expression. We have velocity is directly proportional to the square root of what? Absolute what? Temperature. Take note. That means the temperature must be in what? Kelvin. In Kelvin. Kelvin. In Kelvin. In Kelvin. The temperature must be in Kelvin. The temperature must be in what? Kelvin. Huh? The temperature must be in what? Kelvin.
I have a question.
What's the question?
How we call it V equals to 1 over C squared?
Now it's for indirectly.
So it's wrong, right?
That one is inverse. This one is direct. From this one, directly proportional. If they say inversely proportional, that is what you are saying. You understand? Okay, let us look at it now. Velocity of sound is directly proportional to what? Square root of what? Absolute temperature. That is, the temperature must be in what? Kelvin. The temperature must be in what? K. Kelvin. In Kelvin. The temperature must be in Kelvin. Kelvin. Then from here, change the proportionality sign to the now V equal to what? K root T. Isn't it? Make it the subject of the formula. We have V over root T equal to what? K. Then where you have two velocities and two what? Absolute temperature. We have V1 over root T1 equal to what? V2 over root T2. Take note of this formula. What is V1? Initial velocity. Initial velocity of sound. What is V2? Final velocity of sound. Final velocity of sound. What is T1? Initial what? Initial what? Absolute temperature. Initial absolute what? Temperature. T2 is what? Final temperature. Final absolute what? Final absolute what? Temperature. Final absolute what? Temperature. Final absolute temperature. Final absolute what? Temperature. Take note of that. Take note of that. That is why sound travels faster in the day than in the night. Take note of that. In the day, sound travels faster in the day than in the night. You don't know. In the night, you just hear clearer. Why? Because everywhere is what? Silent. Between the day and the night, which one has higher temperature? Day. And I told you, the higher the temperature, the higher the what? Velocity of sound. That means sound travels faster in the what? In the day than in the night. But in the night, you hear clearer because everywhere is what? Calm. But sound travels faster in the day than in the night. Why? Because temperature of the day is greater than the temperature of the night. Take note. And note this. Note. For every 1 degree C rise. Note. For every 1 degree C rise in temperature, velocity of sound increases by 0.6 meter per second. Take note. For every 1 degree C rise in temperature, velocity of sound increases by what? 0.6 meter per second. For everyone, what?
I have a question, but it's not on this topic.
Okay.
That relationship between the camera lens and the eye.
Camera.
Yeah. You taught those interswitch students use one abbreviation of film like iris is clinical.
I said they are paid Raji Fashola. The similarity between human eye and camera,
Yeah.
pupil, aperture, iris, diaphragm, retina, field. That means pupil perform the same function as aperture in camera. Retina perform the same function as well film in camera. Paid RF. Paid RF.
There's the iris, the Ds.
We are going there, don't worry. We are going there, we are getting there. Okay. For every 1 degree C rise in temperature, velocity of sound wave increases by 0.6 meter per second. Take note of that. Take note of that. Take note of that. Take note of that. In next class, we shall look at question on this. Question on this came out 1998 JAM. Question on this came out 2023 JAM, 2024 JAM on this formula. We are going to look at that. Because of time, at this moment, let us be calling it a day here and make myself chairman. I see you when you see me. May God be with you. Amen.
So I know it's supposed to.
Eh?
How is it close?
It's supposed to.
Is it